Hi folks, I just wanted to be able to go over some of your review with you for tonight because we didn't have enough time to really go over it in class, I felt. So here's your review sheet that you have. I'm just going to go over some of the examples, some of the calculations, and then if I have time, I'll go over the questions on the back of the sheet. Alright, so this is the lab that we did on Friday. As you can see, this is the chromatography paper, this rectangle. This is the place where the pigment was laid by the leaf, and so that is where the pigment origin is. The place where the solvent went to, which was acetone, which we marked with pencil, was up here. That's called the solvent front. That's how far up the liquid went. So as the solvent, acetone, went up the paper, it picked up the pigment from this line that we laid on it. We picked up the pigment and it deposited the different types of pigment as it went up the paper. So we were left with two greens, an orange, and a yellow. Now I know that yours wasn't as clearly differentiated, but we'll go with this example for our calculations. So we have chlorophyll A, B, carotene, and xanthophyll. If you want to do a calculation of RF, which is basically a comparison of how far the pigment went compared to how far the solvent went, then you just take the distance traveled by the pigment from the origin and divide it by the distance traveled by solvent from the pigment origin. So for example, if I wanted to do this for carotene RF, I take the distance traveled by the pigment from the origin. So the pigment in question is carotene. So if you look over here at carotene traveled 3.5 centimeters. And the distance traveled by the solvent from the pigment origin, okay, here's the pigment origin. The solvent traveled all the way up here. This is the same for each of the pigments, okay? It traveled 6 centimeters. Okay, so 3.5 divided by 6 is 0.58. So basically what this is saying is that the carotene went 58% of the way that the solvent went. You should be able to calculate the RF value for xanthophyll, chlorophyll A, and chlorophyll B as well. All right. So the reason why our leaves turn orange in the fall is because they no longer produce chlorophyll, which is green, and then instead they produce the orange and yellow, which are carotene and xanthophyll. All right, moving down. Okay, the purpose of this activity was to show you guys that even though cell surface area and cell volume increase as a cell gets bigger, its surface area to volume ratio will decrease. Okay, so as you recall, surface area of a sphere is 4 pi r squared. Volume of a sphere is 4 over 3 pi r cubed. Okay, we don't need this equation right now. So let's do 0.5, 1.5, and 2.5, and then you guys can fill in the rest. Okay? If the radius is 0.5, okay, then our surface area equals 4 times pi times 0.5 squared. Okay? 0.5 squared times pi times 4, 3.14, 3.14, right there. That's the surface area. If the radius is 0.5, then the volume 4 divided by 3 pi r cubed, 4 divided by 3 pi 0.5 cubed. Okay? 0.5 to the power of 3, which is 0.5 times 0.5 times 0.5, times pi times 4 divided by 3.52. 0.52. Surface area per unit of volume. 3.14 divided by 0.52 is 6. This just means that for every unit of volume that there is for this cell, there are 6 times more units of surface area. All right. As you do these calculations, you'll notice that the surface area to volume numbers go down. Okay. These numbers will go up, will increase, will increase, will increase, will increase. This will increase, this will go up from 0.52, this will go up, this will go up. But this number will go down, this number will go down, this will go down, and this will go down. And the reason why that happens is because from a small cell to a large cell, even though the surface area and volume have increased, the ratio of surface area to volume has decreased, the ratio. Okay? So for every unit of volume that you have, you will get less surface area as a cell gets bigger. The reason why that is important is because a cell will take in raw materials like sugar and will use it to do cell respiration. And if there's not enough surface area to allow absorption of nutrients, then the cell won't be able to undergo cell respiration and your cells will die. So that's why we have really tiny cells, because they have a lot of surface area to volume ratio. Okay? The last section right here wants you to calculate percent change and then explain why you got the results that you did. Okay? So let's figure out the percent change if the initial mass of the potato was 2.39 and the final mass was 1.56. All right. So percent change equals final mass minus initial divided by initial and times it all by 100. So the final mass here was 1.56. The initial mass was 2.39. The initial mass was 2.39. Times it by 100. 1.56, 2.39 divided by 2.39. You get negative 35%. Negative 35%. So the reason why it's negative is because the potato has lost mass. It started as 2.39, it finished as 1.56. So it makes sense that it lost mass, negative 35%. You should get a percent change of 0 for this one. You should get a percent change of, I think it was a couple percent, because you're just going from 2.39 up to 2.45. You actually gain mass there. So it should be positive. The last thing I wanted to show you guys was your potato osmosis experiment and why you got the results that you did. Okay, you guys had 3 beakers. Okay, beaker 1, beaker 2, beaker 3. All right, and in each beaker you had potatoes, and we're just going to draw a picture of what their cells are doing. So this one had 0 teaspoons of salt. This one had a couple teaspoons. This one had 4 teaspoons of salt. All right. So if there's 0 teaspoons of salt, you have a lot of water outside the potato, and you only have a little bit inside the potato. So water wants to go from high to low concentration, and so it will begin to fill the cell. Water goes in. And if water goes in, you'll have an increase in mass. Okay? So if your potato started at 2.39 grams, it's going to go up to maybe like 2.45 grams. Okay, you will see an increase in mass. Now say you put in a little bit of salt, 2 teaspoons of salt. So you put some salt in, like that. Now, there's no salt in the potato. There's some salt outside. Salt cannot cross a cell membrane, it's too big. Water can cross cell membranes. So instead of the salt trying to get in the cell to basically diffuse itself, to go from high to low concentration, instead of the salt moving in, the water inside the potato will move out in an attempt to somewhat dilute its environment. Okay? So if water is leaving, you're going to lose mass. Okay? And there's more salt outside than inside the potato, so we call this a hypertonic solution. Okay? Now, we did the exact same experiment, but we put 4 teaspoons of salt. This means that there is much more salt outside the potato than there was inside. Okay? And you can see up here, it's much more salt molecules. So this means that more water than before is going to try to leave to dilute the environment. So if even more water leaves, you lose even more mass. And if you lose even more mass, you're going to get an even bigger decrease in mass. So instead of gaining mass, this one loses. So maybe it went from 2.39 to 2.30. This one would have went from 2.39 to maybe 2.12. Okay, so you have a bigger decrease in mass. This is also a hypertonic solution because there's way more salt molecules outside than inside. So the more hypertonic the environment gets, the more water is lost. If we had a situation where the potato didn't change mass, it went from 2.39 to 2.39 after 15 minutes, that would kind of give us a clue that if it doesn't lose mass, that means that the amount of water going in the cell must be the same amount leaving. And so what that means is that if there's 3 molecules of salt on the inside, there's also 3 molecules on the outside. So we call this isotonic. It's already in equilibrium. The number of salt molecules on the outside equals the number of salt molecules on the inside. All right, so you should be able to answer all the questions on the back, and that'll be a majority of your marks for open response. Okay? If you guys have any other questions, you can search on YouTube. Okay? This you could look up under leaf chromatography. This you can look up as surface area to volume ratio of cell. And this you can look up as potato osmosis. Right? Good luck.